So let's continue, my dear friends. So if you've seen the last class, we were doing probability, right? Today, let's wind up the probability and let's wind up the mathematical expectation concept as well. Okay. Now, so if you've seen the last session, we have completed everything related to set number B. Now let's proceed further and let's complete set number C. Now coming to this set number C, 2-3 sums we have solved in the last session. In this session, let us complete everything related to set number C. Now, the questions will be on little higher side, but yeah, we should be in a position to do them. There's no issue. Now, question number 1. What is the probability that a leap year selected at random would contain 53 Saturdays? A leap year selected at random would contain 53 Saturdays. If you see, my dear friends, a leap year, how many days a leap year has? Obviously, sir, leap year has 366 days. Okay, fine. So a year has how many days? Sorry, how many weeks? A year has 52 weeks. So 52 weeks into 7 days per week. So can I say 52 weeks and each week 7 days? It's how much it will be 52 into 7? We are having 364 days. So can I say, my dear friends, at any cost in this 364 days, we'll be having 52 Saturdays. That's the pakka. Yeah, 53 Saturdays. I'm sure that in this 366 days, for sure in this 52 weeks, we'll be having 52 Saturdays. Okay. So in 366 days, I know the picture of 364 days. Now let's go and analyze the balance 2 days. Now, what do you think these 2 days can be? These 2 days can be either Saturday, Sunday, or Sunday, Monday, or Tuesday, Wednesday, or Wednesday, Thursday, or Thursday, Friday, or Friday, Saturday. Saturday, Sunday, Sunday, Monday, Monday, Tuesday also. Monday, Tuesday. Okay. So total, how many possibilities we are having? Total, we are having 7 possibilities. Total, we are having 7 possibilities. So total cases are equals to 7. We want Saturday, right? In how many cases we have Saturday here? Can I say this is one case and this is one case where we are having Saturday? So I'm sure that favorable cases are 2. So what's the probability? Probability is 2 divided by 7. Okay. So what is the probability that a leap year contains 53 Saturdays? It is 2 by 7. Okay. So answer is 2 by 7. If it is a non-leap year, that is the normal year, then answer will be 1 by 7. Okay. Next. Question number 2. If an unbiased coin is tossed 3 times, what is the probability of getting more than 1 head? Getting more than 1 head means you can get 2 heads or you can get 3 heads. Okay. You can't get 4 heads, right? He's telling getting more than 1 head. So you can get either 2 heads or 3 heads. In how many cases you'll get 2 heads? 3 by 8 cases. In how many cases you'll get 3 heads? 1 by 8 cases. So total 4 by 8, which is equals to 1 by 2. Next. If 2 unbiased dice are rolled, what's the probability of getting points in neither 6 nor 9? You should not get 6, you should not get 9, he's telling. Okay. So can I say 1 minus getting 6 or 9? Instead of doing neither 6 nor 9, I'll do 1 minus getting 6 or 9. 1 minus. What is the probability of getting 6? On how many cases you will get 6? 5 by 36 cases. In how many cases you will get 9? 4 by 36. So if you see 1 minus 9 by 36. So 9 by 36, 0.25, which is 0.75. So 1 minus 0.25, which is equals to 0.75. Already, my dear friends, this dice rolling and coins tossing, already we have seen in the last session. It's just an extended sums of all these things. Now, what is the probability that 4 children selected at random would have different birthdays? Now, 4 children are there. First, let us take total cases. 4 children. First child can take birth in any of 365 days. Second child, any of 365 days. Third child, any of 365 days. Fourth child, any of 365 days. This is total cases. Next, favorable cases. Now, first child can take birth on any of 365 days. Let us assume that fellow took birth on January 1st. Can second child take birth on January 1st again? Absolutely no, because he's telling there should be on different birthdays. So 364 days. Next child, 363 days. Next child, 362 days. I hope you understood this because he's telling different dates must be there. First person take birth on January 1st. No other child can take birth on the same day. Say, for example, second child has taken birth on February 14th. No person can take birth on that day again. Okay. So 365 cancel. So 364 into 363 into 362 whole divided by 365 whole cube. Okay. So what's the answer? Answer is option A. Next. Question number 5. A box contains 5 white and 7 black balls. Okay, let's see. He's telling there is a box. Okay. This box contains 5 white and 7 black balls. Total how many balls are there? 7, 10, 12 balls are there. 2 successive draws of 3 balls are made. You are taking out 2 successive draws of 3 balls. 3 balls, 3 balls. First is with replacement. Second is without replacement. The probability that the first draw would produce white balls and the second draw would produce black balls. Okay, that's a given question. The probability that the first draw will produce white balls and the second draw will produce black balls. First, let's do with the replacement. With replacement. With the replacement means you are taking out the ball. You are taking out 3 balls. You are seeing them. You are placing them back in the box again. First, I need to select 3 white balls. How will I select? 5C3 divided by 12C3. Favorable cases by total cases. Favorable cases 5C3, total cases 12C3. Now, again, I need to select 3 black balls. 7C3 divided by 12C3. First, I'll select 3 white balls. I'll place back in the box. Again, I'll take out 2 black balls. I'll place them back in the box. Now, let's see what is 5C3. 5C3 is 10, sir. What is 7C3? 7 into 6 into 5 divided by 6. 35. Now 12C3. 12 into 11 into 10 whole divided by 6. 220. 220. I can cancel 0 and 0. 5 sevens. 220 divided by 5. 544s. So 7 divided by 968. This is with the replacement. Okay. Now let's do without replacement. So now let's do without replacement. This is question number 4. Now let's do without replacement. So let's see, my dear friends, how it happens without replacement. First, I'll select 3 balls from 5 white balls. 5C3 by 12C3. Now, my dear friends, after taking 3 white balls and seeing I'm not keeping them back in the box, I'm throwing them aside. Now, when you're throwing without replacement, you're throwing the white balls aside. How many white balls are left? 2 white balls. How many black balls? 7 black balls, total 9 balls. Now I need to select 3 black balls. 7C3, be careful, total cases will change. 9C3. In with replacement, total cases are not changing. In without replacement, total cases are changing. Please keep a note of this point. Okay. Because here balls have changed. In without replacement, there's a reduction in number of balls. So obviously total cases will change. 5C3 is 10. 12C3 is 220. 7C3 is 35. 9C3, 9 into 8 into 7 divided by 6. 84. 0, 0 cancel. Next. 7 5s. 84 divided by 7. 7 12s. So 5 divided by 22 into 12. 264. 5 divided by 264 is the answer. Simple sum, nothing much difficult. First is with replacement, second is without replacement. In with replacement, total cases will not change. In without replacement, total cases will change. Next, question number 6. There are 3 boxes with following composition. If one ball is drawn at a random, then probability that it would be of same color. But unfortunately, he didn't say what is that color. He just said it is same color. He didn't say what is that color. Okay, sir. See here. We are having 5 red, 7 white, 6 black. Total 18 balls. Next, 4 red, 8 white, 6 black. Total 18 balls. 3 red, 4 white, 2 blue. Total 9 balls. He is telling one ball is drawn at random. What is the probability that they would be of same color? Let's check. Let's check. They would be of same color. This is box 1, box 2, box 3. Now I can select red from box 2, box 1, red from box 2, red from box 3, or white from box 1, white from box 2, white from box 3, or black from box 1, black from box 2, black from box 3. For a blue, blue, blue from box 1, box 2, box 3 respectively. Now favorable cases. Now first let me tackle total cases. From 18 balls, I need to select one ball, 18C1. So many insects are there today. (18C1), 9C1. Total cases. Now first, red from box 1. 5C1 by 18C1. 4C1 by 18C1. 3C1 by 18C1. Plus, now white, 7C1 by 18C1. 8C1 by 18C1. 4C1 by 9C1. Now let's do for blue. 6C1 by 18C1. 6C1 by 18C1. 2C1 by 9C1. Now 5 into 4 into 3. Whole divided by 18 into 18 into 9. 7 into 8 into 4 divided by 18 into 18 into 9. 6 into 6 into 2 divided by 18 into 18 into 9. First, let's do numerator, my dear friends. 5 into 4 into 3, m plus 7 into 8 into 4, m plus 6 into 6 into 2, m plus MRC. 356 whole divided by 18 into 18 into 9. 2916. Okay, I hope we can make some divisions here. 5 into 4 into 3, m plus 7 into 8 into 4, m plus 72 m plus MRC. So 356 divided by 2916. So let's cancel with 2 table. Let's cancel 2916. Let's cancel using, yeah, two table. 356 divided by 2. 2 178s. 2916 divided by 2. 1458. Again, two table. 178 divided by 2. 89. 1458 divided by 2. 729. So what is the answer, my dear friends? Answer is 89 divided by 729. Simple question. Nothing much difficulty. Only thing is that you need to understand how will you take the balls. Next, question number 8. A bag contains 8 red and 5 white. Total 12 balls. 13 balls, sorry. 2 successive draws of 3 balls are made without replacement. Without replacement means you are taking a ball and you're throwing them aside. You are not keeping them back in the box. The probability that the first draw will produce 3 white balls. 8C3 favorable cases, 13C3 total cases. Now you have taken 3 white balls, is saying. Sorry. 5C3 by 13C3. Now you have taken 3 white balls and you throw them aside. 8 red balls. There are only how many white balls now? There are only 2 white balls. Total 10 balls. So 8C3 divided by 10C3. Be careful, my dear friends. First I have taken white. Next I am taking red. 5C3 is 10. 8C3. 8 into 7 into 6 by 3 factorial. 13C3. 13 into 12 into 11 divided by 6. 286. 10C3. 10 into 9 into 8 divided by 6. 120. 0, 0 cancel. Still. I can use 4 table. 4 threes. 56 divided by 4. 4 14s. Next. Can use 2 table. 2 sevens. 286 divided by 2. 143. So 143 into 3. So answer is 7 divided by 429. Simple question, sir. Yes, simple question, nothing much difficulty. Next. There are 2 boxes containing 5 white and 6 blue balls. 3 white and 7 blue balls. If one box is selected at random and a ball is drawn from that, what is the probability that it is blue color? 5 white, 6 blue, 3 white, 7 blue. 11 balls, 10 balls. You are selecting one ball, the ball is blue. 6 blue balls by 11 blue balls, or if one box is selected random, or 7 blue balls by 10 blue balls. Okay. So LCM 60 plus 77 divided by 110. So it is 137 divided by 110. Sir, but 137 divided by 220 is there the answer. That's correct, my dear friends. Because see, he's telling first box must be selected. What's the probability of selecting box? Total cases 2, because 2 boxes are. I need to select only one box. 1. So the entire probability I'll multiply with 1 by 2. 137 divided by 220. Why I'm multiplying with 1 by 2? Because he's telling you one of the boxes is selected at random. First you have to select a box, then the ball. That's the reason you have to multiply with half. Next. There are 3 persons aged 60, 65 and 70 years. The survival probability for these 3 persons for another 5 years are. What is the probability that at least 2 of them will survive? Survival probability. A 0.7, B 0.4, C 0.2. Survival probability this is. Then what is the death probability? A complement B complement, C complement, 0.3, 0.6, 0.8. What is the probability that at least two of them will survive? Means A can survive, B can survive, and C can die. Or A will survive, B will die, and C will survive. Or A will die, B will survive, C will survive. Or all A, B, C will survive. He is telling what is the probability that at least two of them will survive. So I can say 2 can survive or 3 can survive. 0.7, 0.4, 0.8. A, 0.7, B complement, 0.6, 0.2 plus A complement BC, 0.3 into 0.4 into 0.2, 0.7 into 0.4 into 0.2. Let's check. 0.7 into 0.4 into 0.8, 0.224, 0.7 into 0.6 into 0.2, 0.084, 0.3 into 0.4 into 0.2, 0.024, 0.7 into 0.4 into 0.2, 0.056. Total 0.388. So what's the answer, my dear friend? 0.388. Be careful. He's telling at least two of them will survive. Means 2 can survive or 3 can survive. There is no issue. Next. Tom speaks truth in 30% cases. Dick speaks truth in 25% cases. What is the probability that they would contradict each other? Truth, false. Tom, Dick. What are the truth probabilities? 30 and 25. 30 and 25. Now, if Tom says truth in 30% cases, obviously he will lie in 70% cases. If Dick says truth in 25% cases, obviously he'll lie in 75% cases. So he's telling what is the probability that the statements would contradict? Means the answer will be one truth, one more false, or one false, one more truth. 0.3 into 0.75 plus 0.7 into 0.25. 0.3 into 0.75 M plus 0.7 into 0.25 M plus MRC. So 0.4, or in 40% of the cases, I'm sure that their statements will contradict. %40 or 0.400. Now before 13th, let's go to another one. 14th we have done. Now let's do 15, 16, 17, 18. Now before going for 15, 16, 17, 18, I want you to solve question number 18 by yourself. How will you solve 18? He's telling P of A complement by B complement. That is P of A complement intersection B complement by P of B complement. That is P of A union B whole complement by P of B complement. So 1 minus P of A union B whole divided by 1 minus P of B. Come on, friends, go ahead and solve this sum. I'll wait for 2 minutes. It's a simple sum, but little lengthy. But please go ahead and solve it. I'll wait for 2 minutes. So first, my dear friends, we need to calculate P of A union B here. So let's calculate P of A union B. P of A plus P of B minus P of A intersection B. So if you see LCM will be 12. 2 into 6, 3 into 4, 4 into 3. 7 by 12. Now 1 minus P of A union B. 1 minus 7 by 12. 5 by 12. Okay. So 5 by 12. 1 minus P of B. 1 minus 1 by 3 will be your 2 by 3. So 3 ones, 3 fours. So 5 divided by 8. Five divided by 8 is the answer, not 1 by 2 ones. Check it. How did you get 1 by 2? Or did I do any mistake? Achha, that's fine. You took P of B as 1 by 2. And what about you, Geeta? I hope you changed. Because both of you got the same answer, 1 by 2. Okay, fine. No issue. Now, question number 16. So, okay, chill, it happens. Let's see what he's telling. He's telling 8 identical balls are placed at random in 3 bags. What is the probability that the first bag will contain 3 balls? 3 boxes are there. First, let's calculate total cases. First ball can go to any of the 3, second any of the 3, third any of the 3, fourth any of the 3, fifth any of the 3, sixth any of the 3, seventh any of the 3, eighth any of the 3. So 3 power 8. Now favorable cases. Total 8 balls you are having, right? In these 8 balls, first select 5 balls. How many balls is telling? We'll go to first bag. 3 balls. First, I'll select 3 balls. Take these 3 balls, keep it in the first bag and seize it. Take these 3 balls, keep it in the first bag and seize it. Okay. Now, my dear friends, from 8 balls, 3 balls are over. How many balls are left? 5 balls. First ball can go to any of the 2, second any of the 2, third any of the 2, fourth any of the 2, fifth any of the 2. So probability 8C3 into 2 power 5 divided by 3 power 8. 8C3, 8 into 7, 35. 56, sir, not 35. 2 power 5, 32. 3 power 8, 1, 2, 3, 4, 5, 6, 7, 8. 6, 5, 6, 1. So 56 into 32 divided by 6561. 0.2731. So what is the answer? Answer is simple, 0.2731. Next, question number 15. A packet of 10 electronic components is known to include 2 defectors. If a sample of 4 components are to be selected from the pack, what is the probability that the sample will not contain more than 1 defective? Okay. You are selecting a sample of 4. So question number 15. Total cases will be how many balls are there? How many bulbs are there? 10. 10C4. What is 10C4? 10 into 9 into 8 into 7 whole divided by 24, which is 210. Now let's take favorable cases. 10 bulbs are there in which 2 are defective. Obviously, 8 are good. Okay. He is telling what is the probability of selecting if a sample of 4 components is selected at random. What is the probability that the sample does not contain more than one defective? Does not contain more than one defective. Means, can I say, my dear friends, we can have 0 defective and 4 good, or we can have 1 defective and 3 good. Yes, sir, because he's telling sample cannot have more than 1 defective. Means it can have 0 defective or it can have 1 defective also. Now, how will you select 0 defective from 2 defective? 2C0 into 8C4, 2C1 into 8C3. 8C4, 8 into 7 into 6 into 5 divided by 24. 70 plus 8C3, 8 into 7 into 6 divided by 3 factorial into 2. 112. So 182. So probability is 182 whole divided by 210. We are having 182 divided by 210. Let's check. 210 divided by 15, we have 14. 182 divided by 14. I can use 14 table. 182 divided by 14, 13. 210 divided by 14, 15. So my dear friends, answer is 13 by 15. I'm using 14 table. 14, 13's 182, 14, 15's 210. Okay, simple sum? Yes, sir, simple sum. Question number 17. Yeah, question number 17 we'll do. First, let's do that lengthy one. Then we'll come back to the small one. Question number 17 is very small. Question number 19. 20, 21, 22, 23, 24. 1, 2, 3, 4, 5 questions are based on mathematical expectation. He is telling 4 digits 1, 2, 4, 6 are selected at random to form a 4-digit number. Total cases. How will you arrange 4 numbers in 4 places? 4p4, 4 factorial, 24. Now, favorable cases. The number should be divisible by 4. It must be divisible by 4 means the last 2 numbers must be divisible by 4. 1, 2, 4, 6 are there. I need to take 2 numbers in such a way that they will be divisible by 4. I'll say 12 is divisible by 4, 14, 16 is divisible by 4. 21, no, 24. Yes. Next, 41, no, 42, no, 46. No. 61, no, 62. No. 64. Yes, 64. First, 12 is divisible, 16 is divisible, 21, 24. Yes, 24 is divisible, 26 is divisible. 61 is not divisible, 62, 66. Okay. Now, so 4 numbers, any one number can be placed. Now, balance 2 numbers can be placed in 2 places in 2 factorial ways. So 4 into 2, 8. 8 by 24. 1 by 3. Okay. 4p1 into 2 factorial, which is 8. And 4p4 is 24. So 8 by 24 simply equal to 1 by 3. Now, next. See this question, my dear friends. This much lengthy we may not expect in the examination. 13th is a little lengthy sum. But yeah, we can practice and go. There are two boxes. First box contains 3 red, 5 white. Total 8 balls. The second box contains 4 red and 6 white. Total 10 balls. A ball is taken at random from the first urn and is transferred to second urn. You are taking one ball from the first urn and you are transferring to second urn. Now another ball is taken at random from the second urn. The probability that the second ball would be red. This second ball is red ball. He is telling that you will take one ball from box 1 and place it in the box 2. But he didn't say which is that ball. It can be either white ball or it can be either red ball. See ya, my dear friends. Let's solve this. Question number 13. You are having two boxes. First box contains 8 balls. Second box contains 10 balls. From first box, you are taking one ball and you are transferring to the second box. After that, from the second box, you are taking out red ball. After that, from the second box, you are going ahead and picking a red ball. The first ball, what you are transferring, can be either a white ball or it can be either a red ball. So two cases are possible. So case 1. You transfer white from box 1 to box 2 and take out red from box 2. That's what you transfer white from box 1 to box 2 and take out red from box 2. This is one case which is possible. Second, you transfer red from box 1 to box 2 and take a red from box 2. This is one more case possible. Be careful, my dear friends. Second ball, what you are transferring is red ball only. First ball, it's your wish. You can transfer either red or white. But second ball, what you'll transfer only and only red ball. Okay. How will you select white ball from box 1? 3C1 by 8C1. Now, if you see in box 2 position, 4 red are there. Now you have transferred from 1 white ball, right? So 7 white will be there. So total 11 balls. Now I'll select red from box 2. 4C1 by 11C1. 4 into 3, 12. 8 into 11, 88. This is case 1. Case 2. You're transferring red from box 1 to box 2. 3C1 by 8C1 into. Now if you see the second box case, earlier 4 red were there. Now since you added 1 red, 5 red will become 5 red are there. 5 red and 6 white. 6 white only. So total 11 balls. Now you will take out a red ball. 5C1 by 11C1. 15 divided by 88. So in first case, it is 12 by 88. Second case, 15 by 88. So total 27 divided by 88. Okay. So question number 13, my dear friends. 27 is not there, so 35 is there. Let's check 4 into 3, 12. 5 into 5. Sir, you are transferring a red ball, sir. 5C1. You are transferring a red from box 1 to box 2. So 5C1 into 5C1. 25. 25. 37. So what is the answer? 37 divided by 88. Okay. Now question number 17, my dear friends. Last question in the set number C. I'll give you 2 minutes. Just think and see whether you can crack it or not. 17th one. X and Y stand in a line with 6 other people. Okay. What is the probability that there are 3 persons between them? Okay. X, Y, 6 people are there. Total cases. 8 people can be arranged in 8 factorial ways. Okay. Now, favorable cases. He is telling X, Y, there should be 3 people between them. Okay. Then other than these 3 people, balance how many will be there? 4, 5, 6. Or if there are 3 people here, 1 person, 2 person, 3 person. He is telling X and Y stand in a line with 3 people between them. Do you know from the 6 people who are those 3 people? No, sir, I don't know. So from the 6 people, first I'll select 3 people and I'll place in between them. I will take this entire thing as one single unit. Whole box as 1 unit. Now total how many units are there? 1, 2, 3, 4. How will you arrange 4 things in 4 places? 4p4 or 4 factorial. Can this X and Y interchange among themselves? These 5 things cannot interchange among themselves because he's telling there must be 3 people between X and Y. So X and Y can interchange among themselves. 3 people can interchange among themselves. So answer is 63, 6 into 5 into 4 divided by 3 factorial. That is 20. 4 factorial is 24. 2 factorial is 2. 3 factorial is 6. 8 factorial. 8 into 7 into 6 into 5 into 4 into 3 into 2. 40, 320. Divided by 20, divided by 24, divided by 2, divided by 6. So answer is 1 divided by 7. Okay. I hope it's fine. Simple? Yes, sir, simple. So my dear friends, all set number C sums are completed. Let's proceed further. Now, let's go ahead and discuss mathematical expectation first. So we have discussed everything related to this probability. Now let's go ahead and let's understand mathematical expectation. Random variables, also called as stochastic variables. Nice name. One minute. Now, random variables or stochastic variables. What are this? Already I said you. What do you mean by random experiment? Any experiment which has random outcomes is called as random experiment, right? Now, before starting with mathematical expectation, first let us understand probability distribution. What is this probability distribution? What is frequency distribution? If frequencies are assigned to random variables, it's called as frequency distribution. In the same way, what is probability distribution? If probabilities are assigned to random variables, it's called as probability distribution. See here, I'll show you. See this example, my dear friends. See here. When you're tossing 3 coins, what are possible outcomes? Either you can get 0 heads with respect to heads, or 1 head, or 2 heads, or 3 heads. What is the probability of getting 0 heads? 1 by 8, 3 by 8, 3 by 8, 1 by 8. So can you see what's happening here? You are assigning probabilities to random variables. This is called as probability distribution of tossing 3 coins. Probability distribution of tossing 3 coins. Okay, this is how we get probability distribution of tossing 3 coins. What about probability distribution of tossing 2 coins? 2 coins. Random variables. You can get 0 heads, 1 heads, or 2 heads. Probability 1 by 4, 2 by 4, and 1 by 4. Okay. So what is probability distribution, my dear friends? If you are assigning probabilities to random variables, that's called as probability distribution. That's it. Now, I'm rolling 2 dice. Let's see what's the probability distribution. Random variables, you can get some as 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Probability 1 by 36, 2 by 36, 3 by 36, 4 by 36, 5 by 36, 6 by 36, 7 by 36, 8 by 36. Sir, what nonsense? 6, 7, 8, 9, you're going. No. 5 by 36, 4 by 36, 2 by 36, 3 by 36, 2 by 36, 1 by 36. Means, can you see what's happening, my dear friends? You are assigning random variables and probabilities together. That is called as probability distribution. Okay. Fine. Now see this, my dear friends. Let us go ahead and let us take this example further. So I hope you understood what is probability distribution. So probability distribution means simply assigning random variables to probabilities. We call it as probability distribution. Now, what is this mathematical expectation? Mathematical expectation means, my dear friends, if you multiply random variables and probabilities, we call it as mathematical expectation. This mathematical expectation is also called as mean or mu. Sir, why is mean called as mathematical expectation? Simple. What is the formula for mean? For discrete data? Summation of observations into frequency divided by sum of frequency, right? Here observations are random variables and frequency is probability divided by sum of probability. So sum of random variables into probability. What is sum of probability, my dear friends? 1. So denominator is 1. That is the reason formula for mathematical expectation is summation of random variables into probability. See here. See this example. This is the given data what I have. Probability distribution of tossing 3 coins. I want mathematical expectation. This is denoted by symbol E of x or mu. I'll do sum of random variables into probability. 0 into 1 by 8 plus 1 into 3 by 8 plus 2 into 3 by 8 plus 3 into 1 by 8. 0 plus 3 by 8 plus 6 by 8 plus 3 by 8. 12 by 8. It's nothing but 1.5. Sir, probability should not be greater than 1. How did you get greater than 1? No. Mathematical expectation can be. There is no issue. Mathematical expectation can be greater than 1. Nobody stops you. Okay. So I hope mathematical expectation is clear. U of x, sum of random variables into probability, x1 into p1 into x2 into p2, so on till xn into pn. Next, variance. We know already variance, right? How will you get variance? Standard deviation square. How will you get standard deviation for discrete data? Summation of, if you see, we have summation of x square into f divided by summation of f minus mean square under root. This was the formula, right? Short formula. Summation of x square into f divided by summation of f minus mean square. Now, since it is square, standard deviation square, I will not take this root symbol. I will not take this root symbol because standard deviation square. summation of random variable square into probability divided by sum of probability minus mathematical expectation square. Now, what is sum of probability, my dear friends? Obviously 1. So, sum of random variable square into probability minus mathematical expectation square. Okay. Now, see here in this case, variance I want. Sum of random variable square into probability minus mathematical expectation square. 0 square, 0 into 1 by 8. 1 square, 1 into 3 by 8. 2 square, 4 into 3 by 8. 3 square, 9 into 1 by 8. Minus 1.5 whole square. 0 into 1 by 8, obviously 0, sir. Plus 3 by 8. Plus 12 by 8. Plus 9 by 8. Minus 1.5 whole square is 2.25. So 3 plus 12 plus 9. 24 divided by 8. 3 minus 2.25. This entire value is 3, which is equals to 0.7. Okay. This is how we'll get variance. So I hope it's clear. What do you mean by probability distribution, mathematical expectation, or mean, variance? Next. These are 3 different ways, my dear friends, how that person will denote variance. Either he can write E of x minus mu square, or he can write E of x square minus mu square, or he can write E of x square minus E of x whole square. Any way he can write, there is no issue. There are different notations to show the variance. Okay. Next. Mathematical expectation of rolling, tossing 3 coins. Just now we calculated 1.7, 1.5. Tossing 2 coins 1, rolling 2 dice 7. If you want, you can calculate. There is no issue. Okay. Now, my dear friends, this mathematical expectation properties and mean properties will remain same. What is mean of constant? Constant. Mathematical expectation of k into x, k into e of x. Straightforward questions will be asked, don't worry. E of x plus y, e of x plus e of y, e of x minus y, e of x minus e of y, e of x into y, e of x into e of y, provided x and y are independent. Straightforward questions he'll ask, you need not worry about that. Now, 8th point and 5th point is pending. We'll come back to these points. 8th point and 5th, both I'll teach you while doing sums. So I hope it's clear, my dear friends. What is mathematical expectation? Mathematical expectation means simply you are doing random variables into probability. You call it as mathematical expectation. What do you mean by variance? Random variable square into probability minus mathematical expectation square. Now, what I want to people to do is that take question number 20, take 4 minutes, calculate mathematical expectation, calculate variance. How will you calculate mathematical expectation? Random variable into probability. How will you calculate the variance? Sum of random variable square into probability minus mathematical expectation square. Calculate standard deviation, root of variance. I want you people go ahead and solve this question number 20 and tell me the answer. I'll wait for 2 minutes. See, he's telling 1, 2, 4, 5, 6, question number 20. One, 2, 4, 5, 6. Probability is given. How much is your probability? 0.15, 0.25, 0.15, 0.25, 0.2, 0.3, 0.1, 0.2, 0.3, 0.1. So this is the random variables and this is the probability what he gave. First, let us calculate mathematical expectation. Sum of random variables into probability. So 1 into 0.15, 2 into 0.25, 4 into 0.2, 5 into 0.3, 6 into 0.1. So 0.15 m plus 0.5 m plus 0.8 m plus 1.5 m plus 0.6 m plus MRC 3.55. Okay. Now variance. Summation of random variable square into probability minus mathematical expectation square. So 1 square into 0.15, 2 square into 0.25, 4 square into 0.2, plus 5 square into 0.3, plus 6 square into 0.1, minus 3.55 square. So first, let me compute everything, this one. Let me do this. 1 into 0.15 m plus 4 into 0.25 m plus 16 into 0 m plus 25 into 0.3 m plus 36 into 0.1 m plus MRC. 15.45, 3.55, 12.6025, 2.8475, standard deviation 1.6874. That's approximately equals to 1.69, I hope. Yeah, 1.69. 1.69. That is root of 2.8475. Okay. So I hope it's clear, everybody. Simple sum. Nothing much difficulty in this. Straightforward sum. Okay. Now, let's go for question number 21. He is telling a packet of 10 electronic components is known to include 3 defectives. Okay. 10 electronic components is known to include 3 defective. Means can I say 7 good? If 4 components are selected at random, what is the probability? What is the expected value of number of defectives? You are selecting 4 components. What is the expected number of defectives? What is the expected value of number of defectives? Expected value of number of defectives. First, let's check total cases. From 10 components, I'll select 4 components, 10 C4. 10 into 9 into 8 into 7 divided by 24. 210. Now, random variables. My dear friends, is asking number of expectations or number of defectives. Either you can select 1 defective or 2 defective or 3 defective. Can I select 4 defectives? No, sir. There are only 3 defectives. How the hell you will select 4 defectives? You are selecting total 4 components, right? In this 4 components, if 1 is defective, obviously 3 are good. If 2 are defective, obviously 2 are good. If 3 are defective, obviously 1 is good. No probability. 1 defective, 3C1 into 7C3 whole divided by 210. 3C2 into 7C2 whole divided by 210. 3C3 into 7C1 whole divided by 210. So what's the probability? 7 into 6 into 7 into 6 into 5 divided by 3 factorial 35 into 3. 105 by 210. 7 into 62. 63 by 210. 7 by 210. This is a random variable. This is probability. Let us multiply random variables into probability. 1 into 105 by 210 plus 2 into 63 by 210 plus 3 into 7 by 210. First numerator. 1 into 105, m plus 2 into 63, m plus 3 into 7, m plus MRC. 252 by 210. 1.2. So what is the value here, my dear friends? Value simply equals to 1.2. Now see this question number 22. The probability that there is at least one error in account statement prepared by three persons are 0.2, 0.3, 0.1. If ABC prepares 60, 70, 90 such statements, then the expected number of correct statements. My dear friends, here probability of error is given, but he is asking mathematical expectation of correct statements. Be careful. Probability of error is given and he is asking mathematical expectation of correct statements. Wow. See you. First, probability of error. First, random variables. 60, 70, 90. Probability. Probability of error he gave. And what is the probability of correct statements? Complement. 0.2 complement, 0.8. 0.3 complement, 0.1 complement. Now, mathematical expectation is random variable into probability. 60 into 0.8. 70 into 0.7. 90 into 0.9 is equals to 178. 178. Next. Before 23, I want you people to solve 24. He is asking you to calculate variance, but here K is missing. I hope you know, my dear friends, sum of probability is 1. Yes, sir, we know sum of probability is 1. So can I say K plus 2K plus 3K plus 3K plus K will be equals to 1? 1, 3, 6, 9, 10. 10K is equals to 1. So K is equals to 1 by 10. Or it will be 0.1. So if I change everything over here, remove K, K, K. 0.1, 0.2, 0.3, 0.3, 0.1. Now, my dear friends, random variables are given, probability is given. Can you calculate variance? Yes, sir, we can calculate variance. First, we need to calculate mathematical expectation. Mathematical expectation. Random variables into probability. Sum of random variables into probability. 1 into 0.1 m plus 2 into 0.2 m plus 4 into 0.3 m plus 6 into 0.3 m plus 8 into 0.1 m plus total 4.3. Now calculate variance and tell me. I'll wait for 1 minute. Variance also I will only do. What you will do? Come on, calculate variance. So let's do this variance. Random variable square into probability minus mathematical expectation square, right? So this is the formula for variance. Now random variable square. 1 square is 1 into 0.1 plus 2 square is 4 into 0.2 plus 4 square is 16 into 0.3. 6 square is 36 into 0.3. 8 square 64 into 0.1 minus mathematical expectation square 4.3 whole square. Let's take 1 into 0.1, 0.1, 4 into 0.2, 0.8, 16 into 0.3, 4.8, 36 into 0.3, 10.8, 64 into 0.1, 6.4. So 0.1 plus 0.8 plus 4.8 plus 10.8 plus 6.4, 22.9. Now 4.3 whole square, 18.49, 18.49. That is 4.41. Okay. Sorry. So you'll get exact 4.41. So I hope it's fine. Now, see this question. Question number 23. In this question number 23, we can even understand what is the use of mathematical expectation. Okay. He is telling a bag contains 6 white and 4 red balls. If a person draws 2 balls and receives 10 rupees and 20 rupees for white and red respectively, then what is the expected amount? He is telling a bag contains 6 white and 4 red. There's a bag. This bag contains 6 white and 4 red. Total 10 balls are there. Okay. So a person draws 2 balls. He receives 10 for white and 20 for red. What is the probability of expected amount? See, my dear friends, 23. Now, 2 balls is drawing, right? When he is drawing 2 balls, he can draw either 2 white balls or 2 red balls or 1 white, 1 red ball. Now, if he draws 2 white balls, how much amount he'll get? For 1 white, he'll get 10 rupees. For 2 whites, he will get 20 rupees. For 2 red balls, 40 rupees. For 1 white and 1 red ball, 30 rupees. So these are the random variables what we have here. 20, 40 and 30. Let's calculate probability. How will you select 2 white from 6 white? 6C2 by 10C2. 2 red from 4 red, 4C2 by 10C2. 6C1 into 4C1 by 10C2. First 10C2, 10 into 9 divided by 2, 45, 45, 45. 424, 4 into 3, 6, 15. Okay. So we are having random variables and probability. Let's calculate mathematical expectation. 20 into 15 by 45 plus 40 into 6 by 45, 30 into 24 by 45. Let's get the answer. 20 into 15 m plus 40 into 6 m plus 30 into 24 m plus MRC. 1260 by 45. So it is 28 rupees. So mathematical expectation is 28 rupees. My dear friends, how much ever you struggle in this game, maximum amount what you can earn is 28 rupees. Now, okay, you went to play this game and the person is asking you 40 rupees to play this game. Okay. Mathematical expectation is 28 rupees. You want to play this game, but the person is asking you, please give 40 rupees, then only I'll allow you to play this game. Will you play this game? No, sir, we won't. He's asking 40 rupees and maximum what I can earn is only 28 rupees. Why the hell will I play this game, sir? I won't play. No, okay, fine. Mathematical expectation is 28 rupees. He's asking you 20 rupees. Will you play this game? Yes, I will play this game. That's a fair game. Okay. That's how mathematical expectation will be used in gambling. Especially in financial management, it will be used. When you go to higher levels in financial management, you will understand. See here, that's the same point what I've written here. In a case of a game, mathematical expectation is less than participation amount, then the game is unfair. Mathematical expectation is 28, but that fellow is asking 40 rupees. It's an unfair game. You should not play. Okay. Now, eighth point, last point is pending. Let's look into this. Y is equals to ax plus b. Variance of x is k, then variance of y is a square into variance of x. That is a square into k. Let's do this. See here, my dear friends. Question number 23. Variance of 6, x is 6, variance of y is missing. Do you know in this dispersion concept, in dispersion, we don't consider the constant? Yes, we don't consider the constant. 4, we don't consider. 2x plus 3y is equals to 0. Variance of x is given. So I will write 3y is equals to 2x. Y is equals to 2x by 3. I'll do squaring on both sides. Y square is equals to 4x square by 9. So 4 into, what is variance of x? 6 by 9. 6 into 24 by 9. That is 8 by 3. Sir, why did you do squaring on both sides? Dude, what is variance? Standard deviation square. That's the reason I have done squaring on both sides. Okay. In this question number 22, will you consider the 4? No. If you do squaring on both sides, y square is equals to 9x. Okay. Standard deviation of x. Achha, standard deviation is given. Standard deviation is given means directly y is equals to minus 3x. Minus 3 into 2, 6. But can stand dispersion be negative? No. So positive 6. Simple question. Okay. See here. Variance of a x is 23. He is asking variance of 2x plus 10. Will you take 10? No. I'll do square of this. 4x square. What is x square? 23. 4 into 23. 92. Next, mathematical expectation of x is 4.5. Y is 2.5. X minus y. 4.5 minus 2.5. 2. Okay. So I hope that's fine, everybody. So that's all regarding probability. So probability is done, my dear friends. So rest out things we'll do in the next class.